All right, this is the midterm exam benchmark review. This is the Stokes County exam for Math 2. All the Math 2 students in the county are taking the same exam. I'm trying to be kind of more thorough, so you may see more items and more concepts reviewed in ways that you may not see tomorrow on your exam, but this way I feel like I've done everything I can to get you prepared. So number one, I actually reviewed the definition of congruent. Some transformations produce images that are the exact same size and shape. They are congruent. Others may be the same shape, but not necessarily the same size, which makes them similar. Which of the following transformation does not produce congruent images? Okay, remember, what are we doing if we translate? We are just sliding things around. It still is exactly the same shape, same size. Rotation is when you twist it around a center point. Again, it may be in a different spot, and it may be upside down or sideways, but it's still the same shape, same size. Reflection is when you flip it from one side to the other, maybe across the x-axis or across the y-axis. Again, it still is the same shape, the same size. But when you dilate, you actually change the size. So when you change the size, it is no longer congruent. So therefore, dilations are the ones that do not produce congruent images. Number two, if the parallelogram ABCD is translated 7 units left, 3 units down, consider the resulting image. And it says you may want to draw this. I actually did provide a space here. If you're taking a midterm exam or if you're taking a final exam and you wish to take a problem that's described and it does not have a grid or a graph provided, you can have access to all the gridded paper you want. You can make your own x-axis, your own y-axis, and you can actually put points on that gridded paper so you can see it. So I encourage you to use your gridded paper as much as you might need to or want to. So if I'm going to go 7 units left, I'm actually just going to put this on here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, and then I'm going to go 3 units down, 1, 2, 3. So that would actually be the new D prime. Okay, 1, 2, 3, 4, 5, 6, 7, down 3. This is my new C prime. A is the same way. I'm going to go left, and I'm going to go down 3. So somewhere right there. I just need to construct something that would be pretty much the same. So there's my D prime and C prime. And it's saying which statement is true. Okay, remember, if you just translate, and that's what we did. We translated this. When you translate, the images stay the same. So let's read DC and BC. Well, here's the original DC, and here's B prime C prime. Well, B prime C prime is right here. Are they parallel? No. Next one, AD. A to D. So if I look at A to D, I'm going to look at this one right here. That's A to D original. So A to D original. B prime C prime. Well, C prime, B prime C prime is right here. Are they perpendicular? No, they're actually parallel, and they actually are congruent. So it doesn't match because it's perpendicular. Then it says AB and A prime B prime. Well, AB is right here. That's the original, and A prime B prime is right here. Well, this is 1, 2, 3 units, and I think this is also 1, 2, 3 units. So they are congruent. Are they parallel? Well, this line and this line, they do run side by side and never touch. So far, C is looking really good. And if you double check, AD would be right here on the original, and it's to D prime C prime, which is right here. They may be perpendicular, but they are not congruent, okay? Because this one's actually length 5 and this one's actually length 3, so they are not congruent. So C is correct for number 2. If triangle ABC is reflected, keep in mind, if it's reflected, you are going to create images that are congruent. They're going to be the same shape, same size, different position. It's reflected across the x-axis to create A prime, B prime, C prime. Name the side that's congruent to AC. I don't even have a picture, but if you wanted to use gridded paper to draw a triangle and then reflect it across the y-axis, you would be free to do that. I don't know where A, B, and C are located, but I do know, okay, that this is side AC. So A is first, C is the last. It should be congruent to what? A prime, C prime. I just think that that was pretty easy to understand that, hey, those two sides match. and we know that if it's just reflected, it's going to be congruent. Those two sides should be the same length. So that would make them congruent. Dilations produce images that are not congruent. Not be parallel, but don't have to be. Could be perpendicular, don't have to be, but they are similar. Again, I'm just trying to emphasize basic ideas. Number 5 is a different problem. I don't know that we've done a lot, but you are going to see some different kinds of problems. FG has points -1, 3, G 2, 1. If F is dilated with respect to the origin by a factor of 2, find the following. And I've actually went back and pulled up the slope formula. So I'm going to find the slope of FG. Then I'm going to come back and I'm going to find the slope of F prime, G prime, and then I'm going to actually consider my choices because it's mentioning same slopes, different slopes, same slopes. Then it's actually mentioning parallel lines, non-parallel, non-parallel. So if I just visualize this, I can also compare the slope. So if I put these on here, -1 up 3, there's point F. Over 2 up 1, that's point G. There's my line segment. Now what I want to do is I want to do the slope. I can take my y minus y over my x minus x. So I'm going to subtract two numbers top and bottom. So it's going to be y minus y, 3 and 1, over x minus x, -1 and 2. I should get a slope of 2 over -3. Bringing the negative up should be -2/3. So the slope of FG is -2/3. If I had done that on the graph, I should find myself going down -2 and right +3, which also confirms -2/3 slope. Now it also says I'm going to dilate this by a factor of what? 2. How do you dilate points? How did we dilate? Now this is a good time to review. So if you take the x's and the y's that you're given and you dilate factor of 2, I want to multiply 2 times every x and then 2 times every y. So if I dilate these, I'm looking at f prime being 2 times that would be -2, and then it would be +6. 2 times to make g prime would be 4 and 2 because I multiplied both by 2. Now, if I find those new points, put those on the graph, then I'll be able to see what the slope looks like and I'll be able to answer these questions. All right, -2 up 6, +4 up 2. There's my line. Well, I think they're looking pretty parallel. So I do think they're parallel. I also think they look like, because they're parallel, they should have the same slope. That's something that we learned from Math 2. If I calculated the slope of this line, I want to subtract two things, top and bottom, so it's y minus y. So I'm going to grab 6 and 2, -2 and 4, -2 and 4. I'm actually getting 4 over -6. Okay, 4 over -6, bring the negative up. 4 6 does reduce to 2/3, -2/3. So -4 over 6 does reduce to -2/3. So guess what? They have the same slopes. They're also parallel. A should be easy. So dilations do produce images that have the same slopes and the lines are parallel. Remember, when you just dilate, you're not twisting, you're not flipping, you're just making it bigger. So it should look very much the same. Number 6, a shape is dilated, or excuse me, translated 3 units right. If you translate, you're only going to slide 3 units right, 2 units down. So if I remember my function rules, I'm going to be, when I go right, that's in the x direction, so that's going to be +3. Down is going to be in the y direction, and I have to subtract 2. So that's actually what I have. I have my x's +3, and then my y's -2. Then it says, then something else happens. I'm going to dilate scale factor of 4. We just reviewed that when you dilate scale factor of 4, you're actually going to multiply everything times your scale factor. So I'm going to have to multiply every x plus 3. Remember, 3 was already there. So I'm going to multiply the x plus 3 times 4, and I'm going to end up multiplying the y minus 2 times 4. Keep in mind, the plus 3 was there first, the minus 2 was there first. So when I get ready to multiply by 4, I have to multiply everything times 4. So 4 times 3 is 4x. 4x, and then 4 times 3 is 12. 4 times y is 4y. 4 times negative 2 is 8. Negative 8. The answer is B. Number 7. Which best describes the transformation of the triangle ABC to A prime, B prime, C prime? All right. If I look carefully, my picture is not just slid, so it is not a translation. Well, it's either giving me choices of reflection or rotations. Okay. If you'll remember, the line y equals x, okay, actually comes right up through here like this. It's like the y and the x are the same number, so it's like 0, 0, 1, 1. Or that's like a line of slope y equals 1x with a slope of 1, rise 1, run 1, rise 1, run 1, rise 1, run 1. I don't think what's above the line is below the line because my triangle has went from here all the way down to the other side. I don't think they are necessarily, even if I do the negative x, that would simply be going this way. Okay, that might be closer, but if I look, when I translate here, C would have rotated over here, and that looks like it's an A. So it has not been reflected. I checked it, I considered it, but it's not reflected. Now, it actually has to be either rotated 180 or it has to be rotated 270. Let me clean my picture back up. And if I remember, 180 is like going halfway around. If you go all the way around, you go around 360. So if I go halfway around, which basically puts me on the opposite side of the graph. And I think that's exactly where I am here. Notice A is in the top right, but A prime is in the bottom left. They're exactly in the opposite side, so we have a 180 counterclockwise rotation. Actually, the direction does not matter. An office supply store sells arc triangles in 2 different sizes. The large size is a dilation of the small. Find the scale factor. My suggestion is that you find a point and you compare them. I'm just going to randomly say, hey, this one's the easiest one I see. This is C. All right, I'm going to continue the problem. I was looking at point C. I hesitated because I did notice that my points are C and C prime. But if I read the problem, it's basically saying the large size is a dilation of the small size, and it's basically saying find the scale factor. So I interpreted the problem as I was going from the small triangle up to the big triangle. If I do that, I'm actually going from a point that's over 2 up 1 to a point that's on the big triangle that's actually over 4 up 2. And if that's the case, it looks like my x's got 2 times bigger and my y's got 2 times bigger. Scale factor would be 2. Now, when I've taken a second look at this problem, okay, if I ignore the description of the large size to the small size, I do want you to know that I just realized that I should have had, this is C, this is C prime, which means this should have been the one I started with. This should have been the one that I ended with, which means that I actually went backwards. I go from the big triangle to the small triangle, which would have basically said I went from 4 to 2. I actually got half as big. So if you wanted to say, you know, I think in the picture, Miss Jessup, the scale factor should actually be a half, I would actually have to say I agree. But in looking at the description, and I actually copied this problem from another source, so I'm going to chalk that up to not carefully considering what the picture looks like and just assuming what the description was describing. But we've discussed it thoroughly, I think. Number 9. ABCD is rotated 180 degrees with respect to the origin. Rotated 180 degrees. Again, we're going to talk about that with respect to the origin. 180 degrees is halfway around. So if I go 90 degrees, I'd be over here. Remember, 90 degrees. And you go with respect to the origin. So if I went here, somewhere over here, that might be 90. That would be 90. But I have to go another 90, so I'm going to go somewhere down here. So remember, 180 puts me exactly in the opposite quadrant, the opposite side of the graph. So I'm going over 2 and up 7 to get to B. B prime should be in the exact opposite direction. I should go backwards 2 and down 7. Right there, I think, is where B prime is. Notice that I really didn't use a rule, but we actually had a list of rules that you have in your notebooks and your binders. Please pull those out. Use those to help you study for this midterm exam. So that would actually be left 2 and down 7. So left 2 and down 7 is choice B. Now, we do not really do much with quadrants, but it's never a bad thing to refresh. What are the quadrants? Well, if you start in the top right, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So as an extension question, vertex B prime lands in which quadrant? So I think you know that it lands in quadrant 2. So we use the Roman numeral 2, or you can simply write the number 2. Number 10, quadrilateral ABC is reflected, should be ABCD, is reflected across the y-axis. This time I'm going to highlight my axis, and I have to realize that every point that's on this side is going to have a matching point on the other side. So A prime should be about right there. B prime should be over here, about right there. And this would be D prime, and then C prime would be over here. Okay, and I could actually sketch, and notice that what's to the left has been switched to the right. What's to the left has been switched, what's to the right has been switched to the left. I'm talking about the coordinates of vertex C prime. C prime are over here at -5 up 6. So I'm actually at -5 up 6. -5 up 6. So having a picture really helps me see what I'm looking for. If they do not provide you with a graph, please use gridded paper and do it yourself. All right, vertex C prime lands in which quadrant? Miss Jessup messed up on the last one. That is not quadrant 2. That is quadrant 3. How silly of me. I hope that somebody out there was screaming, Miss Jessup missed that. Miss Jessup missed that. This is quadrant 2. So this is quadrant 2, or the number 2. So sorry. I'm very tired. Number 11, the function rule. Which function rule best describes the findings of the table? So they've given you the pre-image and the image, and they're wanting to know which one of these rules. Now, these are all rules that we did when we did our transformation unit. This one right here is actually said the x comes to the front, the y goes to the back, but everything stays the same. This one says the x stays in the front and goes opposite, y stays in the back, stays the same. Now letter C says x stays in the front the same, y in the back just goes opposite. And in D it says I'm going to move the y to the front and it goes opposite, x goes to the back and stays the same. These are all rules, and I actually have the rules memorized. You do not have to memorize the rules, but you should be able to find a pattern. So let's just refresh. We actually did this very same pattern. I'm noticing that my 2 is in the back, but over here my 2 is in the front. 3 is in the back, then I have a 3 in the front. Of course, that's 3, 3. -3, -3. I have a -1 in the back, now 1 is in the front. Okay, and notice that it did go opposite. 0 is hard to tell because 0 doesn't go opposite. 5 is in the back, now 5 is in the front. So we did have things switch places. So since I know I had some switch places, it's not B and it's not C. It's either A or D. I also noticed when it came to the front, so when 2 came to the front, it went negative. So that's opposite. So that's actually the rule for a 90-degree counterclockwise rotation. I have that one memorized. Again, they say you shouldn't memorize them, but you should actually be somewhat familiar with what those are and how to use them. Number 12, if a line segment MN is rotated 90 degrees counterclockwise, then the resulting image M prime N prime would be formed. So they didn't give us a graph, and I actually copied or tried to look at an actual released item test question and tried to understand what they were going for. So I'm just going to say, let's say I have a line segment right here. Okay, this might be M, this might be N. They don't tell me the coordinates, so I don't need to know it. But I do know that it's going to rotate at 90 degrees counterclockwise, which means I'm going to take this point and I'm going to make it rotate 90 degrees counterclockwise. So it makes a 90-degree angle right here. Okay, so that would be like M prime. Should be M prime with a M prime. So I'm just trying to eyeball it. Okay, this one up here should actually end up way more farther up here. So that might be N prime. So there's my new segment. It's the same length, it's not perfect, but it has been rotated 90 degrees counterclockwise, which is backwards the way the clock goes. And it's basically saying, what would be the generic equation of any point on this rotated line segment? So if I look over here, I'm actually going to go over and up. So I'm actually going to go, let's see if I can describe this best. This one right here, I'm going over positive and up positive. This one I'm going what? Left, which is negative, and then I'm going to go up, which is positive. So I'm having some signs change. I'm having some signs change. So since I am seeing a sign change, I know it's not going to be B because I'm going to cross that one out. And I also, actually, we just reviewed 90 degrees counterclockwise rotation, and this mentions a 90 degrees counterclockwise rotation. So the generic version would end up being C. Again, you could put it on a grid. You could put it on a grid and actually try to visualize it. 13, which best describes the transformation? Did it rotate? Did it rotate? If it rotated, try to find my pencil. I'm going to orient right here. So if I rotate this 90 degrees, P would have been right here. Okay? If I rotated another 90 degrees, P would have been where? Down here. So if you rotate, imagine rotating and then rotating, orient your P. It's actually about the same shape it would be, but my P is not in the right location. Okay, so it was not rotated. So I'm going to go ahead and just scratch off the idea that it was rotated, which means this one is going to either be a reflection across y equals x, which means is it a rotate across this line, or is it rotated across y equals negative x? And I think hopefully you can see that if I look carefully across, it's not across y equals negative, it's actually across here. So if I have my line right up through here, y equals positive x, everything on this side of the line has a point that matches on that side, and the distance should be the same. This side should match this point, and that's t prime. So it looks like we're looking straight across our graph. Sure enough, everything above the line has a matching point below the line, so A is the correct answer. I'm hoping that as we're going through this, it does seem to make sense. Now, I have a red triangle, a red square looking figure, blue square to a light green square. Which combination of transformations? In other words, we did more than one thing to this. Now, I want you to notice that I have A right here, regular A, so that means this one is my pre-image. This one right here is A prime, which means my blue one is my second image. And then this one right here on the bigger one is actually A double prime, which means it's my final and resulting image. So how did I go from red to blue to green? Well, I think we can see it looks like I got twice as big. And I'm saying dilation size 2, dilation size 2, dilation size 2. But if I go in order, I did not do the dilation first. I actually look like I moved it from red to the blue position, then I made it bigger. Okay? So it would have to either be A, B, or C. Did I reflect it across the line y equals x? Okay, remember the line y equals x would be up through here. Nope, it did not go from one side of the line to the other. Did it rotate 180 degrees? Well, everything that would be to this side would have a matching side on this one. Remember, it's the exact opposite side of the graph. This one's not. It did not rotate. It should translated left 3, down 2. And if I check that, I do believe that works. Because it looks like I go 1, 2, 3, and then down 1, down 2. Left 3, and then down 2. And I believe that works. And then it got bigger. All right, what type of symmetry does the figure possess? Rotational symmetry about the 0.86. Reflection across the line y equals x. Keep in mind this is a special line. How do I graph the line y equals 6? Y equals 6 means it just touches the y-axis, and it touches it at positive 6. I also want you to look closely. I actually pulled this diagram from a released exam. So they're going to expect you to study a picture and realize that this one is not marked off in ones. It's actually marked in twos. So I would go 2, 4, 6, 8. And this would go 2, 4, 6, 8. So these are marked off by twos. So if I go to find y equals 6, I'm going to go to the y-axis to 2, 4, 6. And if I drew a line, that would be my line. And I reflect it across that line. Well, I hope you can see the top side does not match the bottom side. So I do not think it's a reflection across that line. Next one. Oh, I didn't look at the first one. Did it do a 180-degree rotational symmetry? Let me refresh what rotational symmetry is. Rotational symmetry is when I can do a screen grab and I imagine taking my picture, did it grab my picture? Guess it didn't. Let me try again. Do a screen grab. Here we go. There we go. So if I take this one and it says 180-degree rotational symmetry, which means what if I rotate this? This is 90-degree rotation. This would be 180-degree rotation. Does that look like that? Nope. Kind of looks like a kite, and the kite is now upside down. So when I rotate it, so rotational symmetry is if it's got to rotate however many degrees you say, and it's got to look exactly like the first one. So I did not rotate it 180 degrees. Rotation about the 0.86. So basically if I came over 8 and up 6 and I rotated it around that point, well, it's almost like you put your finger and you'd rotate it around. It does not rotate 90 degrees. If I rotated it 90 degrees, then I would end up with a kite something like this. Does everybody kind of make sense? It would not be exact, it would not be symmetrical. What about a reflection across the line x equals 8? That's a special line too. So when I look at the line x equals 8, I'm going to go to the x-axis to that number 8, 2, 4, 6, 8. It only touches, so I'm going to go right down through here. I think that's our answer. If I look at the left side and imagine flipping it to the right side, right down the middle, I would actually have the same thing. It would actually have very good symmetry. Okay, next question. We just kind of reviewed rotational symmetry. So think about taking a screenshot. Think about taking your paper or your screen on your Chromebook and turning it, physically picking it up and twisting it upside down. If I turned it, would A look exactly the way it looks right here? And the thing of it is I can do a screen grab and we can confirm it. Okay? So if I take a picture and I rotate it, man, that looks exactly the same. Rotate again, still looks exactly the same. So it's got a lot of rotations. I can move it just a little bit of degrees, use it more degrees, and I can see that it rotates. Okay? What if I grab the butterfly? Does it have rotational symmetry? I hope that you remember that no, it does not. My butterfly, if I rotate it, does not look the same. No matter what angle. I can even go 180 degrees, it looks different. What about the, looks like the McDonald's M? Does it have rotational symmetry? No. If you did screen grab it, okay, remember, rotational symmetry, you've got to rotate it and it's got to be totally identical to the beginning. And if I grab this one at any position when I rotate it, doesn't look the same, doesn't look the same, doesn't look the same, doesn't look the same. It looks different. It has symmetry on a line, but that's not. We're not doing line symmetry. We're just doing rotational symmetry. Okay? And I hope that you can see for a similar reason the VW symbol, no. So the only one that has rotational symmetry is A. So it has been a few days since we've talked about rotational symmetry. I hope that really comes back to you. What are the angles of rotation? Angles of rotation. Well, if you'll remember, what we do is we take this was like a slice of an orange or a lemon, and I would start at the mark and I'd say, well, I could rotate from here to here and it would look the same. That's once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. So if I rotated this thing 8 different times, I would be right back to the beginning and it would look very much the same. So I remember that I go 360 degrees all the way around. But if I have to divide that into 8 times, I think I end up with 45 degrees. So when we used to make our list, we would say 45 degrees. Then if I rotate another 45, that'd be 90. Another 45 past 90 would be 135. And these are considered to be multiples of 45. 45 being the first. It does not work with 60. 90 would work, but you're leaving out some. 120, it does not work. Okay. Hopefully that rings the bell. 18. Which function maps a figure onto a congruent image? So Miss Jessup's coming back to this term of what? Congruent image. Congruent means that even when I change it, I end up with something that's exactly the same shape and size. Okay. What you want to look out for in these rules, are there any rules that does change the size? If there's a rule that does change the size, then I know it's not going to be congruent. Okay? So that's really all we have to look for. So it looks like right here in this first one, I switched the places. Looks like X came to the, Y's came to the front, X's went to the back, so I did some switching. But what did I do right here? I changed the size. That one gets 2 times bigger. That's a dilation. That will not keep it congruent, so that one's out. Letter B. Looks like I added 2. That just slides it. I came down 3 to Y's. That just slides it down. So that still makes it the same. What did I do here? Ooh, I just switched places. I think that's what a reflection does. Well, I did not change the size. Right now, B is looking pretty good that it probably would still stay congruent. What about in C? What did I do here? Oh, 3x. As soon as I see 3x, I know that means what? That's a dilation. I'm making it 3 times bigger. That is not going to keep it congruent. So that one's out. What about D? Look at the first rule. What did I do right here? 1/2 x. So I think that's going to be a dilation that's not going to make it bigger. It's actually going to change the size and make it smaller, but it's still considered a dilation. So that means that one's out too. So the only one that would create a congruent image is B. Guys and girls, they are emphasizing the fact that when you do your translations, rotations, and reflections, those images stay the same size and shape. They are congruent. When you do a dilation and you change the size, then it becomes similar. So any kind of question like that, just kind of know how to focus your attention, refresh today, and we'll be good to go. 19, set up and solve a proportion. Find your matching sides, write your first fraction, and then make the second one match it. I'm going to start at 6, and I'm going to write it compared to 15. So I know 6 compares to 15. So I'm going to come back and say, well, I started with the 6 triangle, or pentagon, so I'm going to have to go back and pick the 2. That matches up to 2, and 2 matches up to x. 6 compares to 15 in the same way 2 compares to x. I hope that you remember crisscross multiply. So I get 6x is equal to 30. Divide out the 6, x is equal to 5. Solve for x and then y. Solve for x and then y. This one can be misleading because there's actually 2 different kind of things going on here, and I picked one problem that's going to review 2 things. First one, if I'm looking for x, I'd like you to notice that I've split it. This is a piece and a piece. The other side, I've got the x piece and the 15 piece. That's actually from the side splitter theorem. I don't know that you need to remember that name, but I'm just going to remember, or just going to remind you, that was the side splitter. So if you split those sides, then you can actually compare the sides. So that means 3 compares to 9 in the same way that x compares to 15. And I should be able to solve for x that way. Again, crisscross multiply. 9 times x is 9x. 3 times 15 is 45, I believe, divided by 9. X equals 5. Looks like this one is the correct answer. Let's confirm the other one. The other one is going to be a little bit harder. I'm going to clean this up. Hopefully, if you need to go back and do that, you can always pause these videos. You can fast forward if you already know how to do a question. Okay. I want to take a look at this one. When I solved for y, I did not split a side. Y matches up to 12. But notice that y is on a small triangle, And 12 is actually on a much larger triangle. So I actually have a small triangle within a big triangle. So I have to compare small to big, small to big. Remember, I used to do this too. I would also, sometimes I would split that. That's 3x and y. And if I drew the big one, then I have to ask myself, how much is it all the way across here? Well, this is 3, this is 9, so this left side would be 12. And then the back side by here is 12. I have 12 and 12. Okay. We're not solving for x. We've already got that. So if I set that up, I think 12 matches up to y in the same way that 12 matches up to 3. That's not the only way. See, 12 to y, 12 to 3. There's pretty, I think y is going to end up being 3, which it should be. So you have to use similar triangles to solve for y. Please don't forget that. A triangle within a triangle. Okay, set up and solve for x. How can I use my picture to solve for x? Keep in mind these marks. That's 2 marks, so it should match this one that has 2 marks. So 7x minus 4 side should match up to 31. So I want to solve for x. I'm going to bring the 4 over here. So I'm going to add 4. 7x is equal to 35. So x would be equal to 5. All right. Now, 2 mark side matches 2 marks. This one has 3 marks. This one has 3 marks. So 4y plus 8 should match up to 24. So 4y plus 8 matches up to 24. Take the 8 over here and subtract. 4y is equal to 16. Divide by 4. I think y is equal to positive 4. Okay. Not trying to go too fast, but we have a lot to cover. The 2 triangles are congruent by what reason? Congruent. I'm going to clean this up. You can always backtrack. You can always read that part again. There are 5 reasons that we can have triangles be congruent. And the congruent symbol is actually this equals with a squiggle over it. First way we learned was side, side, side. Actually, they're all listed right here. Side, 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 angle, side, angle, side, angle, 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 side, and HL. So if I look at this one, I have one side that matches that side, 2 sides, 3 sides. This one is side, side, side. Which figure below shows triangles that are congruent? All right. I do have a shared side on A, so I could technically put 2 marks. You only have to do, so I'm going to look at this bottom triangle and I'm going to say, well, that side was marked, that side is marked, and this angle is marked. But that's angle side, side. That's not one of them. Matter of fact, that's the one that does not exist because you cannot do that one. So that one is a big no. It is not congruent. I'm looking for which figure below shows triangles that are congruent. I have 5 to look at. Letter B, side and an angle. Not enough. So that one's a no. Have to have 3 parts unless it's HL. Okay, letter C. Well, I do have a right angle. Oh, looking straight across from the right angle, that is my hypotenuse. But I don't have a mark on it, so I can't really put an H on that. Well, I do have a shared side in the middle, but that only gives me an angle and one side, and that's not enough. 2 parts is not enough. Letter D, I have 3 marks, which matches 3 marks, 2 marks, which matches 2 marks. It looks like I have side, side, which looks at first like maybe it's not, but look closely. Is there something that you can mark that's not already marked? I hope you see the X-shaped angles are vertical angles. So when I put that in there, I end up with side, angle, side. So that one's side, angle, side. So far, D is congruent. Okay, I do have vertical angles here again, but even if I mark those, I get an angle and one side, and I don't have enough information. So I had 4 no's and only 1 that actually worked. Okay? Again, that's a quick review. I happen to notice, and I'm not sure, but on your paper, only choices A, B, and C showed up. I let it slide because actually the correct answer is in A, B, and C. So even if you don't have D on your paper, you can still find the correct answer. You can use your congruency statement. I'm here to tell you, if you didn't even have a picture, you should be able to do that. Let me say that again. If you didn't even have a picture, you can do that. Because A should match up, because it's first, should match up to what? M. AM, 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 AO. Of course, D's out. Okay, B matches up to N. B to N, B to O. This one's out. So far, B is out, D is out. Okay, C matches up to O, C to O, C to N. Of course, we already knew B was out. C to O, we already knew B and D are out. So now I've narrowed it. Now I have to go back and check my line segments. AB is the first two, MN. AB and MN, AB and MO. Now I know C is out. A has to be the correct answer. Remember, if you have a congruent triangle, there are 3 angles that are all equal, and there's also 3 sides that are equal. You don't even have to have a picture. You can just do it from the statement. This is an isosceles triangle. These 2 marks mean 2 equal sides, which means 2 equal angles. These 2 angles opposite are equal. So if this is 74, that means the triangles have to all add up to be 180. So if I take 180 minus 74, I think I get 106. Now that means that I have 106 degrees that I have to split. Half of it would go there and half of it would go there. So if you divide that by 2, you're going to end up with 53 degrees here and 53 degrees here. So angle C would turn out to be 53 degrees. Hopefully you do remember your marks and your angles. A suspicion, and I'm worried and concerned that you may not at first want to dive into number 27. But let me encourage you to take it one small chunk at a time. This is a good time to review because now we're going to review our angles. I see alternate interior. That one's mentioned. It's actually mentioned in all choices. Alternate interior are your Z-shaped angles. Please use a highlighter on this review. And if you want to just copy the figure on paper when you're doing it off the computer, you can also highlight on your paper. I know that's not ideal to have to recopy a picture, but it might give you the best advantage. Vertical angles. Vertical angles form an X. Okay. Corresponding angles form the F shape. They're in the same spot, in the same position. Linear pair forms a line because the little word line is actually in the word linear. So basically, in a pair means I have 2 angles. So if I have 2 angles, maybe I have an angle right on here, and then I have a second angle. That's a big angle right here. But those 2 together make a straight line. So that's a linear pair. So look for lines. So let's see if we can make relationships. Okay. It might actually be easier to do some of the questions, and then we'll jump back up and do the choices. Now, if you wanted to pause it, go back, and kind of recopy some of those notes I had, feel free. That's the beauty of having a recording. Okay, 28. If I check B and G form an X. Those are going to be vertical, G and B. Number 29, B and C. B and C. Here's C, here's B. Those form a Z, alternate interior. Refer to the figure above, angle A and angle E. Angle A and angle E. Here's angle A, here's angle E. Do you notice that they form a straight line? These are going to be a linear pair. Refer to the figure above, angle F and the 45-degree angle. Angle F and the 45-degree angle. So I'm going to highlight with yellow. Here's angle F because we did some highlighting, and here's 45. Do you see the F shape? So remember, these 2 lines with these arrows means that the lines are parallel, okay? So we're on this side of the line and on top of the parallel line. So those are corresponding. So C is corresponding. Now let's see if we can make connections. Well, I know corresponding angles look the same, so they are the same. So if this is 45, F is probably also 45. I'm just taking it a few at a time. Okay, what else do I see? Well, I'm going to jump down here. I'm going to clean this up a little bit. Okay, clean it up a little bit. All I have right now is 45. I happen to notice a linear pair right here. Anybody notice a linear pair? So 107 is this part. So how much would B be? Well, if I take 180 minus 107, I think I get 73. So B is 73. Well, let's see. The B angle and the C angle were Z-shaped. They're the same size. They're equal. So C is also 73. See how I'm taking it chunks at a time, small pieces, trying to make connections, trying to remember my shapes. I have a triangle right here. Did y'all see the triangle I just highlighted? I got 73 in there, I got 45 in there, and now I have D. How would I find D? Well, I could say 73 plus 45. I think that gives me 118. And then I know there's 180 degrees in a triangle, so 180 minus 118. And I think I get, did I do that right? Yeah, 118. I want to say 62. Let me check. I think that's right, 62. So D is going to be 62 right here. Let's see if I can get this, 62. So D is 62. So now we've got 4 down, 3 to go. Okay. Anybody notice right here, I see X-shaped angles? Well, B is 73, so guess what G turns out to be? It's the same shape, so G is also 73. Okay, 2 more to go. Now I'm going to have to connect A and E. Well, it's kind of busy, so I'm going to clean it up again. And I only need A and E, and I think I can get them right here. Do we see a line right here? 45 is this part, and then E is this other part. That forms a straight line, and all the way across from here to here is 180 degrees. So if I take 45 from 180, E turns out to be 135. So E turns out to be the bigger angle. It's the biggest one I have, 135. Now I'm just up to A, and if I look closely, do you see F and A are X shapes? So if this is 45, then A is also, guess what? 45. So you do have to remember your triangle sum is 180. Remember your connections with your vertical, your interior, your corresponding angles. Those are the ones that are the most important. The ones that we have here are the ones you definitely need to know. Mid-segment. 32 is a mid-segment. Okay, this tells me that this is in the middle. And these 2 marks here and here tells me those are in the middle. So basically the X plus 4 is a mid-segment. Notice that it is short compared to this one. So if I want to try to solve for X, I have to remember that it's only half as long. So if I had another X plus 4, then this length all the way across and this length all the way across should be the same. So basically to solve, I have to take X plus 4 and double it. And that would be as much as the bottom one, 4X minus 2. Multiply, multiply, 2X plus 8 equals 4X minus 2. I'm going to bring 2X over here and subtract 2X. I'm going to bring minus 2 over here and add 2. I get 10 is equal to 2X. X is equal to 5. Okay, this is a longer video because it's very important. I'm trying to explain as I go. If at any time you need to fast forward or go back and re-listen, please do so. Y. Now when I look at Y is a different problem. Y is right here. So this side, this length, and this length are not different. They're the same. So I can say 4y is the same as 6 parentheses y minus 1. How do I get rid of parentheses? Multiply, multiply. So 6y minus 6 is equal to 4y. I do need my y's together, so I'm going to bring 6y over here. I get negative 2y is equal to negative 6. When I divide out the negative and divide by 2, I get y is equal to positive 3. All right, triangles ABC and RST, notice I don't even have a picture, are similar triangles. The lengths of the sides of triangle ABC, so if I consider ABC, it says that I have triangles ABC, that doesn't look right, let's write it like this, ABC. The sides are 6, 8, and 10. If the longest side of triangle RST, so I'm just going to jot something over here, RST, the longest side is 45. Well, see, this is my short, this is my medium, that means this is my longest. So I want to try to summarize right here. So my longest side of triangle RST is 45, so that would actually be right here. So what is the shortest side? So that would actually match up to what? 6. So I could make up a proportion. Read carefully, set up and solve a proportion. 6 compares to x. In the same way, 10 compares to what? 45. Crisscross multiply. 10x. I think 6 times 45 is 270. Divide out the 10. I'm getting 27. And I'll just jot that right here. So x turned out to be 27. I was just using an x, so I have that first answer. All right. It gives me an extension question. Could I find the perimeter of the triangle? I think you actually had that on your test. The perimeter is the distance all the way around the triangle, which means I would have to know the length of all three. Well, I have 1, 2. I just need the third. Well, if I set up a proportion to solve for the shortest, I could probably set up a proportion and solve for the medium length. And I'm just going to use y for that since I already used x. So 8 matches up to y. Oops, not 8y. 8 matches up to y in the same way that 10 matches up to 45, just like I did before. Crisscross multiply. 10y is equal to 8 times 45. I think that's 360. Divide the 10. Y should turn out to be 36. Okay. So when I want the perimeter, I simply add 27 plus 36 plus 45. My answer turns out to be 108. Okay, moving on. An angle bisector. An angle bisector. That means that it cuts it into 2 parts, but they're actually what? 2 equal parts. So I'm cutting one big angle into 2 smaller angles. But that means that this angle x plus 40 is exactly the same as 3x minus 20, so I should be able to set those equal to each other. So x plus 40 equal to 3x minus 20. So when I bring the x over here and subtract x, bring the minus 20 over here and add 20, I think I'm getting 2x is equal to 40, nope, 60. Divide the 2, so x is 30. Oh, it's asking me to do something else. It says solve for x and also solve for the measure of the angle, QRS, which means I need to put x in, well, I found 30 for x, so put 30 in for x. So 3 times 30, subtract 20. Well, 3 times 30 I think is 90. 90 minus 20. So the angle of the measure of angle QRS should be 70 degrees, which is an imaginary number. So we did that lesson on La Friday a week ago. There is a video. Hopefully some of you have went and read that or watched it. Imaginary number. That's square root of 25. It's just got a negative out front. Square root of 25. That's a perfect square. Since it's a perfect square, it's actually going to come out as just a 5 with a negative out front. Negative 5. Is that imaginary? Nope. Imaginary numbers must have the letter I in them. Having a negative out front is not make it have letter I. That's actually an integer. Integers are whole numbers and whole numbers, but negatives, positives, including 0. It's an integer. And if I climb the ladder, climb that concept map, it's an integer. It's also rational. It could be negative 5 over 1. And it's also a real number. It's on the number line. 2 pi. 2 pi. Is it imaginary? Nope. Has to have an I. So it's not that one. That's actually turns out to be irrational. What in the world is an irrational number? Okay. As a decimal, it does not end or repeat. And pi is one of those numbers that we've talked about how they've tried to find where it stops or where it repeats a sequence and they've not found it. And irrational numbers do not end or repeat. So being irrational does not make it imaginary. What about C? Well, this time I have a negative on the inside. So if I go back and refresh, my I definition is the square root of negative 1. That's where we first started talking about what is I. So if I break that down, that's negative 1 times 81. Well, that means I'm going to bring out or pop out the I. So if I pop that out, I comes out front. 81 is a perfect square. So what number times itself twice is 81? 9. So that actually comes out 9i. Is that imaginary? Yep, it sure is. So C would produce 9i, and that's my imaginary number. And if we go back and just to finish it up, my negative 2/5, that's a fraction. That is the definition of a rational expression. and rational numbers are on the number line, so they're also real. So that refreshes. What is an imaginary number? The volume of a rectangular prism is calculated by the volume. I did not really initially thought I'd put this on the test, but there is no place where we're ever going to talk about volume, but you don't need to know anything about volume. All they're asking you for basically is they threw this right here in. What makes it an irrational value? Took this from a release exam, so I just need you to see that this is the kind of questions that you could run across, things you don't expect. It's basically given me square root, numbers that are in square root form. 4 square root of 3, 3 square root of 6. Which of the following could be the width? So I gave you a hint. Since we haven't done anything like that, I gave you a hint. Review what an irrational number is. Okay, it's a decimal that doesn't end. It's a decimal that doesn't end or repeat. Does not end or repeat. So in other words, it would just have a bunch of decimals across my calculator as far as the calculator goes. Only one results in an irrational final volume. So this is where I would say grab your calculator. Okay, I have turned my calculator on. So now what I want to do is I'm going to imagine how would I do the volume. So it gave me the equation for volume. It's the length times the width times the height. So if I do the volume using this one, the length is 4 times square root of 3. That, even it's messy, my calculator can do it, times the width, which these are the possible width, times the what? Times the height, which is 3 square root of 6. So the first time I'm going to try it, I'm going to say, well, does 2 square root of 50 turn out to be irrational? Is it going to give me a decimal? So 2 square root of 50, okay? 2 square root of 50. So I'm going to grab my calculator, and I'm going to type these in. It's going to take me a second. When you do it on your calculator, make sure you stop the bar. So hit that right arrow right here. Okay, so I'm going to do parentheses, 4 square root 3. Now see, I have to stop the parentheses to stop my bar. Then I have to use extra. So I'm going to have extra parentheses because I don't have a bar that goes. Times, now this time I'm checking out 2 square root 50. It doesn't like it when I try to move it over. So 2 square root 50, close, stop my bar, close parentheses, open a new parenthesis, 3 square root 6, stop your bar. You have to stop your bar with your arrow, and then close parentheses. Press enter. 720. 720. Is that irrational? So even though it looked really messy, I got a nice, even, neat number. It's not irrational. That one is rational. Okay? I can make 720 look like a fraction by putting it over 1. So those nice numbers are not irrational, they are rational. So your goal is to do this for each one of those. Again, the length and width stays the same. So when I do the next one, I'm going to keep 4 square root 3. Oops, I'm writing it wrong. I'm tired. 4 square root 3. Okay. This time, and 3 square root 6 at the end. And you can put these in any order. This time I'm going to try 4 square root 12. Okay. And I would check all 4 of them. And it turns out, do not retype everything. Remember your second entry key? I'm just going to pop back up and go over to where I have 250, because that's what I used last time, and I'm going to put 4 square root 12, and I'm just going to press enter. Oh, now that one gives me a decimal. It doesn't look like it ends because it's going as far across the screen as what the calculator gives, and I'm thinking that might be the answer. Let's try the next one. I'm going to put 5 square root 8, so let's go back here. Going to go up to the middle one, so I'm going to change it from 412 to 5 square root 8, and delete one of those numbers and change that to an 8. Okay, enter. That one again, 720, so that's good. If I check the last one just to confirm, I think I know my answer is B, because B is irrational. I'm going to have to put 7 and 18, so I'm going to change that to 7, and I'm going to have to insert the 1 and make it 18, and I did. 512. So 3 of these gave me rational numbers. This one gave me 720. This one gave me, I think, 1512. This is rational, and the 720 was rational. This one, though, gave me what? 705 point something, something, something. And as soon as I see 705.453 ... 0.453, and it keeps going, that is your irrational. Now, that was not hard, but it was not anything that we've done a lot of. It's just to try to show you they're going to push you to do things that we haven't done just to see if you can think and reason it out. Okay, 37. This is our proofs. One thing to remember about proofs, when you start your proofs, you always should start with the given, and then you should end with the proof. Okay? So, I have 4 steps. My reasons are not there, but these are all embedded in multiple choice. H is the midpoint. Notice that that is all from given. Okay? You don't have to fill that in, but 37 says number 1 reason should be given. Number 2 reason. I do have to read. Now, how did they get GH and KH? So if I come up here and look, G to H, they're saying, is equal from H to K. So it's like this line segment is congruent to this line segment. And how did I know that? Well, look in here. The very first statement says it's the midpoint. So if H is the midpoint, that tells me it's in the middle. I surely should be able to put 3 marks, 3 marks. I should be able to put those marks. They should be the same length. Now, what reason is number 2? Is it given? No. Okay, we already wrote the given. Given has to be exactly stated just like that. Is it reflexive? Kind of keep in mind, reflexive is anything is equal to itself. So like AC would be equal to AC. So in this case, that is not what I have in step 2. But is it the definition of bisector or is it the definition of midpoint? Bisector would work, but it didn't mention bisector in the problem. It mentioned what? Midpoint in the problem. So I'm actually using the definition of midpoint, not bisector. Number 3, what reason? So if I look at number 3, what reason? Where did this come from? Oh, let me look. Oh, it's right there. So that was actually what? Given again. I had 2 big sections of given. So 339 is a given. Now, notice that Miss Jessup used my picture. So now it's saying the reason number 4. How are these 2 triangles congruent? Well, if I check them and I put S's and A's, that's a side. That's a second side. That's a third side. This is S, S, S. So that would be choice A. Hopefully the proofs, you're going to probably see those embedded in multiple choice, something like this, or maybe where you have to grab and stick it in, but hopefully that refreshes proofs. Triangles can be proven similar 3 ways. Which of the following is not used? AA, that's angle, angle. So if you have 2 angles, well, technically you should know 3, because if you know 2 angles, you can subtract from 180 and find the third. Side, side, side. Now that does not mean sides are equal. It means sides are in proportion. So if I make one side 2 times bigger and then I make all the sides 2 times bigger, then their 3 sides are proportional to 3 other sides. That's side, angle, side. Sides are proportional. Angle is the same. We did not have angle, side, angle when it came to similar. So D is the answer. We did not have an angle, side, angle, not for similarity. We did have that when it came to being congruent, but this question was about congruent. This question was about similarity. Are the triangles similar? If so, how? I got every choice imaginable. Even the one that we just found out, I can about guess it's not D because I threw that one in there just to see if you might go for it. I encourage you to look carefully. How many degrees are in a triangle? 180. So if I take 84.6 plus 30.4 and I add those, 80.6, clear, clear, clear. 84.6 plus 30.4 added is 115. Now, if I take and subtract that from 180, it doesn't matter if it's negative, but my angle should be what? 65. Well, the other triangle has 84.6 and 65. Do I have 2 angles that are equal to 2 other angles? Yes. It didn't look at first like it would, but they are. Technically, you actually have all 3, because if this is 84.6 and 65 and 30.4, then this would have also been 30.4. You technically would have had angle, 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 but you don't have to have all 3. You can stop with just 2. 43, very interesting problem. Solve for X, and I'm telling you the triangles are similar. Solve for X. Now, that means this side and this side are matching. So 9 compares to 2x. Okay. X side down here compares to what? 8. So equals x to 8. 9 to 2x, x to 8. It's a little bit different. So this time when I crisscross multiply, I get something that we've really not done before, but we should know how to finish it. What's 2x times x? That's 2x squared. What's 9 times 8? 72. I am looking for possible 2 answers. Okay? And if I think we just did quadratics, so this is going to throw back to what we did with quadratics, I can divide the 2 and do square roots on it. So x squared is equal to 36. Take the square root of both sides. X is equal to 6 plus or minus. But here's the thing. I'm actually dealing with a real world problem or something similar to real world where it's a length of a triangle. I cannot have a negative length of a triangle. So technically the answer is just the 6, the positive. You cannot have a negative length. Okay. Can you solve this quadratic? Yes, I can. I think these factor. Just remember, if you factor, what multiplies to give 6, so we're using the exponential, that's going to add to be negative 5. And I think it's a 3 and a 2, and it'd have to be negative 3 and negative 2, so x minus 3 and x minus 2. But be careful. You have to split and solve, and so my answer turns out to be positive 3 and positive 2. What are the equation solutions? Okay, this one, x squared and numbers. I can do square roots, or I can even factor this. If I brought this over here equal to 11, I would actually get 9x squared minus 36 is equal to 0. That's actually, I can factor that. What's the greatest common factor? 9. 9 goes into both of those. So if I divide by 9, x squared is left. Divide this by 9, I get minus 4. Look carefully. Now, we could have actually done square roots, but do you recognize this as being dots? Difference of two numbers that are squares. So that would factor into two sets of parentheses, x and x, 2 and 2, and it has to be one of those plus and minus. Split, we're going to get x to be a negative 2, and x is going to equal a positive 2. Negative 2 and positive 2. You could have done square roots on that. You could have divided by 9 and got 4, and square root of 4 would have been 2 plus or minus. Use the quadratic formula. So I have to find my a, b, and c. A is 3, b is negative 5, and c is positive 4. Make sure you keep the signs in front of the numbers. So opposite of b, opposite of b. That's going to make it positive 5. Plus or minus square root. Now I'm going to b squared minus 4ac. B number squared is negative 5 times negative 5 is positive 25. Minus 4 times 3 times 4. All over 2a, 2 times 3. Now, please, please, please remember that what I want you to do is take what's under the square root. Don't take the square root and put that in our calculator. So I get 25 minus 4 times 3 times 4, negative 23. Okay, negative 23. So I get 5 plus or minus square root of negative 23, and then 2 times 3 is 6. Now, the only thing I can do, 23 is not a perfect square, so I have to leave 23 in there. But what happens to the negative? Negatives pop out as letter I. So which answer matches up? Okay, it's not 73. It does have 23, but this one has to have an I. So it would be choice B. Okay. The domain and range of a function can be represented on a graph. List the range below. So this case, do you know which one's range and which one's domain? Well, domain is the pre-image, and range would come from the image. Okay. So I'm going to look right here. The image is this one right here in red. I would be 4, 4. R is 8, 2, I think. And T prime is over 3 down 1. And it says, can you write a function rule? Can I figure out x and y? So keep in mind, I go from this I over here and down to that I. So it looks like I translated it. How much did I translate it? Well, I went 1, 2, 3, 4, 5, 6 units, and I went to the right. So that would be plus 6, so x plus 6. Then I'm going to go down 1, 2, 3, 4. So I went down 4. That's y direction minus 4. Hopefully that does refresh on writing rules for translations. Triangles A, B, and C are similar to D and F. Use the diagram to complete the following. So 48, AB. So AB to DE. Okay, those two. Which ones match? So let's just see. AC to DE. AC to DE. Nope. That one don't work. Okay. AC to DF. Okay, AC, DF. I think that's it. Because it does match. The sides match. How are they similar? How are they similar? Well, we do have a missing side right here. But if we were to set up 8 compares to 24, in the same way 6 compares to my unknown, I'll call that x, we could actually solve for that. But the question doesn't ask me to solve. It's just interesting I could, because it does tell me they are similar, so I know that I can do that. Are they similar by angle, angle? Well, did I have 2 angles? Nope, I only had 1. So it's not side, side, side either, because I don't have all 3 sides listed. So it has to have an angle. And it only has 1. So I have a side proportional to the other side, an angle that matches exactly with another angle, and a side, second side, that would be proportional to that side. So this one's going to be proportional by side, angle, side. 2 sides are in proportion. 1 angle is exactly equal. Okay, we're getting close to the end. 50, the discriminant is part of a quadratic formula under the square root, the b squared minus 4ac part. You can use the discriminant to predict the number and types of solutions you will get from a quadratic equation. Given the quadratic equation, and I'm telling you what the A, B, and C are, which statement is true? The discriminant's 29, the discriminant's negative 11, the discriminant's 25, or the discriminant's 29. So let's just find the discriminant. I only have to do the b squared minus 4ac. I don't even have to do the square root. B squared. B number square would be 3 squared minus 4 times A, which is 1, times C, which is negative 5. So if I do my calculator, 3 squared is 9 minus 4 times 1 times negative 5, 29. So that means it's not going to be B and it's not going to be C. Now, does that mean it's 2 real solutions that are irrational or 1 real solution that is irrational? Well, it is irrational because if I take the square root of 29, remember, that's the part that would be under the square root. So if I go back and I think, well, what would I do with it after I found the discriminant? Well, I know the discriminant is 29. That's going to give me a decimal because the square root of 29 is not a perfect square. Square root of 29, it's a lot of decimals. It doesn't end, it doesn't repeat. It's definitely irrational. The thing of it is, remember how we got that part about plus or minus square root? Could you add a decimal and can you subtract a decimal? Would you end up with 2 answers or would you end up with only 1? You should realize that you can add and subtract, so you should end up with 2. Matching. I'm not going to let you get by with not learning something as much as I can give you about your numbers. Which number is imaginary? Well, we did this one a while ago. I think that's negative 5. That's an integer because it's a whole number. It's also rational because I could put it over 1, and it's also a real number because I could put it on the number line. Square root of 20, I think when we checked it, square root of 20 is one of those numbers that is irrational because it gives me a decimal that doesn't end or repeat. So if that's the case, we said that was rational. So A is rational. 20 is irrational because it doesn't end or repeat. 5 plus square root of negative 25. Oh, negative is underneath. If it's underneath, it comes out as letter I. Square root of 25 is perfect. So actually, that's going to come out as a 5. So that's going to simplify to 5 plus 5i. That actually is not just imaginary. This is a real number in the front. This part right here is the only imaginary part. So together, that's actually called a what? Complex number. So that complex number is C And this one, you only pop out the I, and you also pop out the 5. That one just has the 5 with the I, so that one is my imaginary number. Please, please, please try to get those numbers straight. 2 more to go, or last one. Quadratic equation would yield the solution. There are 2 ways you could do this. You could look at the graphs. You could, like we talked about, you could put this in the equation, and you could look at it in y equals. Okay, if I look at it in y equals, clear it out, let's see, x to the second power plus 3 with an x plus 2. If I look at the graph, does it match? That graph does not match that. I should have a -1 and a +2, so that's a no. You could also factor this. If I factor that, what multiplies give 2, that adds to be 3, that's x and x, 2 and 1, plus, plus, but if you split, you get -2 and -1. And that's what I got. It looks like it does come and fall underneath at -2 and -1. It's really close to the line. B. That does factor. Or if you wanted to, you could put that in your y equals equation. X squared minus x minus 2 graph. I think I found it. It does cross at -1 and it does cross at +2. It does factor x and x, x and x. That is 2 and 1. 2 times 1 subtracts to be 1, because there's an imaginary 1 right there. Bigger number wins the sign, so 2 would get the minus, 1 will get the positive. But when you split, you'd end up with x is +2 and x equals -1. And that's exactly what my solutions show. B is my correct one. And you could check C and D if you did not. Please go back, look at the answer key. Hopefully these are questions. This is a long video. Good luck.